Okay, I'm going to go ahead and get started. Hello, everyone. Welcome to this webinar on the newly released What Works Clearinghouse Practice Guide on preparing young children for school. This is the second of 3 webinars on this practice guide. This webinar will focus on recommendations 3 and 4 on mathematical ideas and mathematical language. This webinar is being recorded. A link to view the recorded webinar will be shared via email to all attendees who registered for this webinar. The full practice guide and supporting materials, including this recording, will also be available on the IES website. The views and opinions expressed in this webinar are those of expert panelists and do not necessarily reflect the views and positions of the WWC. Resources shared during this webinar are not necessarily WWC products nor developed from IES funded work. We will have time for questions and answers at the end of the webinar. If you have questions during the presentation, please submit them in the Q&A box and we will address them towards the end of the webinar. Practice guides are products developed by the What Works Clearinghouse, or WWC. Practice guides provide educators with evidence-based practices to tackle current challenges in education. They combine the best available evidence and expertise on a topic to give educators strategies to use in their classrooms and schools. This practice guide on preparing young children for school is intended for educators in preschool classrooms, those supervising teachers and overseeing educational practices for preschool programs, program directors and coordinators, district and state personnel, and parents and caregivers seeking to help children. This slide lists the 11 panel members who collaborated to develop this practice guide. Our presenters today include our panel chair, Peg Burchinal from the University of Virginia, David Purpura from Purdue University, Julie Sarama from the University of Denver, and Elizabeth Schlesinger-Devlin from Purdue University. We'll start this webinar with a brief overview of the evidence levels for the 2 recommendations, followed by an introduction to the overarching themes in the practice guide. Then our presenters will discuss recommendation 3 on mathematical ideas and recommendation 4 on mathematical language, including the corresponding how-to steps. Each recommendation is assigned a level of evidence that indicates the strength of the evidence for the effect of the recommended practices on student achievement. The level of evidence is based on the number of studies supporting the recommended practices, whether the recommended practices were directly tested in the studies or tested in combination with other practices, whether the recommended practices consistently led to improved outcomes within and across studies, and whether the studies capture a diverse range of students and contexts. Recommendation 3 has a strong level of evidence, and recommendation 4 has a moderate level of evidence. I will now pass it on to Peg Burchinal, the panel chair. Peg?
Hello, as panel chair, I would like to start by thanking IES for recognizing the need for an evidence-based practice guide for preschool and for making it happen. I'd like to thank IRG for graciously and effectively shepherding the process, and I'd like to thank all of the panelists for sharing their expertise. As we talked about evidence-based practices that are fundamental for learning, social emotional learning, executive functioning, mathematics, literacy, and language, several practices or themes emerged as fundamental for learning skills in all of these areas. The first practice is the importance of scheduling time for intentional learning. Children learn best when instruction is intentional. This means that it is really important to develop lesson plans, perhaps based on curricula, evidence-based curricula that articulate what, how, and where instruction occurs. In terms of what and how, it is important to plan what is taught in terms of pacing the presentation of lessons from easy to more difficult, in terms of being deliberate, planning how to present new skills, perhaps embedding questions or activities that allow children practice at the skills they're learning, that keep them engaged, and provide a check for the teacher to see the extent to which children are learning these new skills. It also involves ensuring that children have lots of opportunity for actively practicing the new skills, because this is probably when the learning occurs. The second theme that emerged across all the different content areas is the importance of interaction and conversation. We all learn best when we interact and talk with other people about what we're learning. And while it's important for each of us, it's really important for preschoolers. They learn best when they not only hear what is taught, but talk about what they're learning with teachers and peers. Ideally, this involves conversations with the teacher and an individual child that involves at least 3 turns. The teacher talks, the child talks, the teacher talks, the child talks. That's a 4-turn conversation. And while this can happen in whole group, it probably works best in small group, in centers, or in individual interactions between the teacher and the child. The third theme that emerged across all content areas is the importance of lessons building sequentially. New learning should proceed in a deliberate and systematic manner from easy to more difficult. And this means in the fall, it's really important to understand what skills the children entered preschool with, then to introduce new lessons that show how to build off of those skills as you introduce new skills. So in your lesson, really trying to make sure that you're showing how to build off the skills that children already have as they learn new skills. And it's really important to provide lots of practice, both of the new skills and of the already learned skills, to maintain them. Next slide, please. The fourth theme that emerged was the importance of scheduling time for intentional learning. It's important to develop a schedule in which intentional time is devoted to each of the different content areas. It's important that you ensure that instruction specific to each content area occurs, while, if possible, using instruction in one area to repeat or reinforce lessons from another area. For example, if you're reading a book in which a child is frustrated, perhaps you could ask what the child could do to calm down, and ideally hear some of the things that you've talked about in your social emotional learning lesson in that conversation. The final theme that emerged across all content areas is perhaps the most important. And this is the importance of recognizing everyone's background and experience. Preschool should reflect and value the cultural, racial, and linguistic backgrounds of the children, teachers, and communities. Art in the classroom, there should be artwork, books, activities, conversations that reflect who the children are and that celebrate their background. Next slide, please.
Hi, I'm Julie Sarama from the University of Denver, and I will be talking today about recommendation number 3, provide intentional instruction to build children's understanding of mathematical ideas and skills. Next. In order to do this well, use small group instruction. Go beyond basic counting and shapes and include areas that involve more advanced math and that give children a chance to reason mathematically and build up mathematical knowledge from where children are in a sequential manner. Next. Small groups are very effective. Teachers can work with groups of 1 to 4 children, while other children are in centers or with another adult. Again, I'm going to focus on small groups of 1 to 4 children. Many times in my own research, when I'll go into a room and small groups are happening, the small groups are just 1/3 of the class or even 1/2 of the class and can be, 10 children, 12 children. That's not a small group. That's not what the recommendation is. It's for really small groups. And we recommend teachers see children in small groups 10 to 15 minutes a day. Yes, 10 to 15 minutes a day of math. And when you start a small group, start by engaging children, getting them invested in the math topic or the big idea. Next. Then have an interactive, hands-on, fun activity for children that intentionally targets them where they are. Again, building up what Peg said, you don't want to be doing the same activity that's a cute activity you found online in March that you're doing in September. We always want to be looking where children are. And we never want to think that math is drudgery. It's never play versus math. Math can be playful. Give children multiple opportunities to do the activity so they get practice, but also pay attention to what children know and use that understanding to modify activities so children get practice doing what they're still learning. Too much of the time, practice is too easy or too difficult, but you have the ability to differentiate in a small group. If you're in a whole group, it's much more difficult to do. So after you demonstrate, giving them time to practice and hopefully have fun. Next, Elizabeth.
So here's some in-class examples of ways that you can incorporate math together. So as Julie mentioned earlier, small groups. So the photo on the very far left with the children making patterns, the teacher is modeling for them this pattern. Whether you use a pattern card to show the kind of pattern that you want or extend the pattern for children who catch on rather quickly to simple patterns. There's lots of great ways to incorporate patterns, for example, in the classroom, both in small groups and in art. So the photo in the center is an example of how you can also incorporate other multimedia, a stamp pad with stamps that you can stamp your pattern, copy a design, extend a design, do it together in small groups, do it one-on-one. You can also check for accuracy. Are children truly understanding that concept of copying a design, making their own pattern, extending it, adding to it, those kinds of pieces. And the very last part is pattern cards. These are simple, easy cards that you can put out. Children can add the designs right on top of them, or they can build beside them. And some even challenge to build them standing up in a 3D model. Back to Julie.
Thanks, Elizabeth.
No, back to me, sorry. The other way incorporating small groups in the classrooms is thinking about playing games together. And again, small groups, one-on-one, maybe 3 or 4 who can take turns, the idea of whose turn is next, and being able to incorporate those math skills can also incorporate hands-on experiences. You can introduce new concepts with numbers, counting, shapes. You can reinforce those concepts within the games that you're playing. You can also reintroduce a concept if you're not sure a child's totally gotten the aspect of adding more numbers, or maybe we need to look at that one-to-one correspondence again. Games in the classroom provide opportunity for practice and that opportunity to do it in a fun way together and in small groups. Now, Julie.
And now, thank you. All right. Math is so much more than what is typically done in early childhood classrooms. We want to extend beyond what we typically do. Children have the ability and the desire to reason mathematically and talk about their reasoning. Instead of simply naming basic shapes, move to describing their parts and properties and asking them, how do you know type questions. You may need to scaffold their answers. For example, how do you know this is a rectangle? The answer for some children might be 4. Who knows what they're thinking? We're thinking that they, in our own research, that they're probably thinking about sides. But soon, children will be proving to you why a shape is or is not a rectangle, rather than just pointing at one or naming it. Include measurement, which blends understanding of space and quantity, and have children build up from direct comparing to using non-standard units to measure objects. Children love to find out what's bigger and who jumped farther, which is more of a direct comparison. But if we start laying out units, kids can actually attach a number, a quantity to that space and compare thinking about number relationships. And speaking of number relationships, when we teach numeracy, let's go beyond counting to those relationships. Comparing and breaking apart numbers and putting them back together should be included. This helps children understand quantity and serves as a foundation for later math. Back to you, Elizabeth.
So again, some in-class examples of how we can incorporate math into centers in the room, activities that children can come to, leave, whether we encourage small groups with teacher direct interventions, are also opportunities for children to explore themselves. So this is a picture of a classroom, and the center is Legos, and the ability to take those Legos and build on the cards with dots on them. It's also really helpful because we can make incremental changes in the classroom as we see children perform in ways that we might need to scaffold a little more, one direction or the other. Maybe we need to make something a little easier or a little bit more challenging. And so we can change out cards in this example by moving from the dots to number cards. We could also leave blank cards to allow children to create double-digit buildings as they take those Legos and either build on top of one another into towers, or even build into a house with lots of different patterns that can incorporate counting at the same time. So this ability to advance those math skills in engagement with children. Back to Julie.
So we want to build up children's knowledge and skills in a careful sequential manner. Most children follow natural developmental progressions. So they build up understandings in a developmental way. Let's get back to rectangles for a minute. So children are able to only understand whole shapes before they're able to understand parts or properties. So they see a rectangle and they say it's a rectangle because it looks like a door. So they're seeing a whole shape and comparing it to a different whole shape. And they do that before they're able to consider the corners that are right angles and able to talk about that. Another example is when the pattern block puzzles that Elizabeth showed, having different cards for different strengths. If we're thinking about children developing and thinking about their math developing in a sequential manner, it also helps us take an asset-based approach because we're always wondering, what do children know? Next. Consider using a curriculum supplement that follows developmental progressions like learning trajectories. Learning trajectories help teachers link specific instruction to children's development, thereby building up their knowledge to reach a goal rather than starting with a goal and breaking it down into tiny steps. So for example, the child is thinking about rectangles as wholes. Teachers can play games that encourage them to start thinking about the sides and angles and having them feel rectangles and putting them in a feely box and things like that. Learning trajectories are about understanding where children are developmentally and then using the right activity to help children level up to reach that goal. Next, Elizabeth. Oh, I guess I still had one more. To figure out where children are, we need to observe them. And I'm going to go back to small groups. If we're observing children in small groups, we're able to determine where they are in that development. We record where they are, and then we refer back to that in order to plan instruction and make decisions about what activity to give them at the next level. Next. So this is a partial learning trajectory for learning about shapes. Next.
So we're actually going to hold for a second there.
Okay.
So this is an example in the classrooms where we can, as practitioners, engage in dramatic play, incorporating math. This is the construction zone in our classroom with blocks. So being able to work with children, have them design and think about those different block shapes. In the one picture with the child behind it, they specifically have to use terms that help to get the blocks that they need to build and make that design that they have in their minds. We as teachers can incorporate that language of math shapes to talk about what they did with the cube. So this particular child specifically asked for the cube off the shelf. And so being able to connect the verb or the term with the object that they had planned to create this design. The other picture on the PowerPoint includes children creating a house. They all decided that the babies needed to have their own beds, so you can see babies in the background, but they also needed to have their own high chairs. And so in incorporating their building and their design to this, we talked a lot about what kind of shapes are you going to need. When a baby sits in a high chair, are you going to sit them in a rectangle? Or are you going to sit them in a cylinder? Are you going to build really tall walls? Or are you going to build short walls? So we can use the engagement within activities in the classroom to talk about those higher level plans, how we communicate that with one another, and how we can also, as practitioners, share that with children in the classroom. Next slide. So here's an example of a teacher-made observation sheet for recording children's knowledge. When we think about doing observations, one of the pieces that guide all of us in the classroom is to remember to slow down and truly observe what the child is telling us. Don't fill in the blanks for them, even though you really want to cheer and have them connect those parts and pieces together. So here's an example of some math number knowledge skills. You'll see that in our classroom settings, we use things like got it, getting it, and not yet. That idea that got it, that child is consistently showing you those math skills every time you ask a question pertaining to that math concept. In this example, it was number knowledge. Sometimes maybe you do an observation of a child and you notice that it's not quite consistent, that maybe you have to scaffold it a little bit, give them a little bit of cues or hints to help them understand this. And so that's where we would say the getting it section. And then the very last part is the not yet. And really not yet is that observation that's conducted when you're working with a child and you see that they're just not getting maybe those additional numbers. Maybe they have the getting it and got it for 0 to 3, but not necessarily past 3. And so how can we then use those observations to incorporate our activities and engagements with children that we're working with? Next slide, back to Julie.
Yeah, and I wanted to say before I got a little confused, I'm sorry, and I skipped over something I was going to say, is when you showed the pattern block cards, they also can follow a learning trajectory in the sense that giving children really complex pattern cards that don't have lines that are open spaces is much more difficult than having children actually just match the shapes. So if we're using the same pattern cards in the spring that we're doing in the fall, we're probably not meeting children developmentally. And that's where everything that you just showed on those sheets and recording really is going to make a difference in determining what materials we give kids, just like you said about giving them the different kind of counting cards for doing the game. And geometry develops and develops in the same incremental way, just like number does. So I understand that there are potential obstacles. If children have trouble sitting still, try to make activities more engaging and hands-on. Keep verbal instructions short and use small groups rather than whole group. If children are getting bored in math centers, include engaging materials, but most importantly, introduce the center. And I think my colleagues will agree that goes across all centers. Model what should happen there. Children should know what they can do with the materials. You can even take what you did in a small group, move it into a center, so children keep playing independently. Next. I know so many people love kids to sit in circle time, and they really, really like calendar math. But the panel recommends replacing, or at the very least supplementing, calendar with more intentional instruction in small groups, because that is so much more valuable for children. Another potential obstacle is getting frustration in whole groups. Well, small group instruction is better for children because differentiating is easier and it leads to less frustration for children and teachers. It doesn't mean that you can't do some stuff in whole group, but keep it brief and do the kinds of things like finger plays and counting activities that you're really not trying to differentiate. Next.
Hi, everyone. I'm David Purpura from Purdue University. I'm going to share on recommendation 4, engage children in conversations about mathematical ideas and support them in using mathematical language. Next. So with this recommendation, we have 3 how-to steps. The first one is introduce and explain the meaning of mathematical language during intentional mathematics instruction. It's really important to recognize that children may not come into the classroom with knowledge of some of these words, and it's really critical for them to learn these specific words so that they can have access to the other mathematical instruction that you're going to provide. Next, conduct a math-focused shared book reading activity several times each week. Shared storybook reading is something that happens very regularly in classrooms, and connecting it with math can be a great way to integrate the two areas. And then finally, the third step, engage children in conversations about the mathematical ideas and language that they're learning throughout the day. This is really important to make sure that it's not just during that explicit math time that they're using these terms and concepts, but really woven throughout the day so that they can see how math applies throughout their entire life. Next. So with this first step, I think it's really important to first define what is mathematical language. It's the language used to talk about mathematical ideas and skills. It's different than the actual concepts themselves, such as counting and one-to-one correspondence, but the language that underlies early mathematics. There are a lot of terms and concepts that we'll discuss in a little bit, but words like more, many, most, a lot, those quantitative words and spatial words like before, after, near, far are really critical and for understanding early numeracy and math development in general. So first, it's really important to introduce and explain these language terms during intentional small group mathematics instruction. Start with simpler words like long and short, or more and few, and then gradually introduce more complex words with similar or contrasting meanings, such as longer or narrow, or most and fewest, and use some opportunities to explicitly contrast across those terms. Explain the meaning of the words and phrases using words that children already know, and provide concrete examples to explain their meanings. And then have children try to identify where in their environment or the classroom they can also use these words. Also, you can't see it, my hands are waving below the screen, but use gestures to help children understand mathematical language. Next.
So here are some examples of some common mathematical words and their primary topic areas. We share this list as a way to help practitioners think about what those words, those key words can be in engaging with children in math concepts. It's helpful to write these words intentionally on your lesson plans. You could write them on sticky notes to remind you, because I know that I get certainly caught in asking the same kinds of questions over and over again. And so these help remind me that I've intentionally planned to think about different words that I want to focus with children. I can also use these words when it comes times to transition. When I want to transition children from one activity to the next, going outside, for example, can have a little bit of downtime while we're waiting for all of our other friends to come line up with us to go outside. So it's a great opportunity to reinforce these words and talk about the meanings of these words. When we have snack or meal together in children's classrooms, being able to talk about the foods that we're eating and use our math language to help describe the shapes that we see or measurements that we are passing out as we share snack together. In the next slide, you'll see together how we can create a word poster, there we go, in the classroom. So this was actually a fun opportunity for us because we went on a field trip and we took a walk around the building. And so we got to see tricycles, bikes, motorcycles in person, if you would, from a distance safely, of course. But what we got to do then is create together a sorting chart and talk about how many wheels a tricycle had versus how many a bicycle had, the different kinds of textures that a motorcycle wheel had versus a bicycle wheel. They could describe all their parts, and we together could make a poster and then hang it in the classroom as something that we could come back and discuss and talk about together. Next slide, please. Back to David.
One of the things that I wanted to add on to what Elizabeth was saying is that you saw this long list of words, and there are actually many more words as well. But it's not about using as many mathematical language terms as possible. It's about using them intentionally and in the right spots and preparing in advance to use them. So making sure that you're thinking through what are some of the connected words that relate to the math content that we're using, or to other content that I could use these language terms in. For example, with the motorcycle and bicycle and tricycle activities, you can build in words like more or fewer related to the number of wheels. And so think about when you can do that and be very intentional, and also work to have children respond in using that terminology. Now, moving on to the next step. Conduct a math-focused shared storybook reading activity several times a week. The first part of this is choosing age-appropriate books that are likely to be interesting and that include important mathematical content. And I want to preface this by saying that the book doesn't have to be explicitly math-focused, because you can draw the math out of nearly any book. But make sure that this relates to the learning trajectory and the content that you're focused on, not just randomly selecting books and trying to pull out whatever math is in there, but being very intentional about trying to find books that incorporate very specific types of content that you want to build in. Before the reading, read the books and note words or phrases or pictures to talk about, places to stop and discuss a book's content, and questions that you can ask children to stimulate mathematical conversations. This is one of the hardest parts of engaging young children in storybooks, is asking them these rich questions that build on this content. I have 4 kids myself, and when we read at home, it's really difficult for me, and this is something I study, it's really difficult for me to come up with questions on the spot to ask them. So plan in advance. Think about what are some good questions, write them on sticky notes, stick them on the pages, and then as you turn to that page, just pull it off the page, stick it on the back of the book so you can see it, and after you read the text, ask them that rich question. Also, read the book 3 to 5 times during separate math-focused shared storybook readings. The more that children learn the story, the more you can engage them in the mathematical content and get them to extend it even beyond that shared storybook reading experience. And then after each shared book reading session, talk with the children about mathematical ideas or skills and the language that they learned, and try to integrate it throughout your other activities. If you're using the words more or fewer, think about how you can then integrate that during snack time or during time in one of your other classroom centers. Next.
So one of the aspects of the practice guide also includes suggestions in terms of how can you go about finding books that support math-focused concepts. And so the practice guide includes tips for choosing books, some examples of books that help to think about numeracy, geometry, measurement, patterns. And as David was mentioning earlier, thinking about those books ahead of time and the kinds of questions that you're going to ask is helpful to plan it. And so things that we use as strategies in our program is sticky notes. Sticky notes are super popular. You can write down the question, even put it on the page that you want to ask that particular question, or on the cover of the book. Have your 2 or 3 questions that you want to intentionally ask, give time to have discussion with, and make sure that you implement the parts that you've planned for. We also use bookmarks, a way to put a bookmark into that section of the book that you want to highlight that particular math skill or math pattern or math focus that you want the children to pay attention to, and that you want to have that time and opportunity to reflect, discuss. As Peg mentioned very early about those conversations with children, how important it is to have a conversation, listen for a response, provide a response, and have a back and forth together. When we go to the next slide, you'll also see suggestions for how to talk about mathematical ideas in books. And again, the practice guide provides examples with suggestions in how to do these in the classroom. So the mouse ate 1 more cookie. How many did the mouse eat altogether? Sometimes we need some guides ourselves as practitioners to think about the kinds of questions we want to model. We want to think about the kinds of things we want to point out to with children in the classroom. That way too, when we're reading a book, it can give helpful tips for teachers to keep focus and not drift and talk about what your dog did over the weekend, but make sure that you're talking about the math skill that you intended to. Next slide. One of the other areas we talk a lot about is the classroom environment. How can we create the classroom environment to help encourage the opportunity for math conversations, to think about new numbers in practical, meaningful ways? So this is in our dramatic play in the classroom setting. And actually it's old adding machines. Yes, we've unplugged them. And if you can tell, there's tape around them so the cords don't go flying around. But the ability to take the machines themselves, pretend that you're a grocery store and you're adding up the receipt to the purchases that are being bought is another great way to help encourage that pretend play, that imagination, but to incorporate those math activities, those math language into the meaningful exchanges that you have with children. Next slide and back to David.
So for the third step, engaging children in conversations about the mathematical ideas and language they're learning throughout the day. I alluded to this a little bit in the last set of slides, but it's important to engage children in conversations about mathematics beyond just that small period of 15 to 20 minutes that we're recommending for explicit instruction. That time should be explicit, but it really should be woven throughout the day because children view their world mathematically, and helping them to understand how to use the language to talk about and understand their world is really critical to their development. Find ways to use new mathematical language many times during conversations to provide children with multiple opportunities to hear and review the words and phrases. And it's not just, like I said before, it's not just using as many words as possible, but being very intentional with which words you're using and making sure that children really understand the meaning of those words and aren't just using them to use those words. Also, ask questions that will encourage more than one word answers from children to encourage them to think and talk about mathematics. Prompt them to use these mathematical words and phrases in their responses. So trying to get them to really actively engage in this language, both in terms of hearing from you, but also using it themselves. Next.
So some more examples of classroom settings that we can use our questions to encourage more detail, exactly like David mentioned in the slide before about asking questions that elicit more than yes, no answers. Thinking about ways that we can help children think about those math responses can happen in many different places in the classroom setting and can also be playing. So the first picture of our child is standing on top of a mat that happens to be rainbow, and they happen to notice that these were rainbow color strips that were rectangles. And so then we could encourage that child to talk about, well, how many rectangles do you think you can jump over? So not only are we adding math and counting how many rectangles we jump over, we are using the language of rectangles. We're also thinking about what happens if you jump backwards and forward. And so being able to incorporate those large motor skills in the mathematical questions that we can incorporate in large movements such as this one. The other photo in the slide is of our sensory table with water in it. It's a great opportunity to encourage those more small groups that maybe partner together, one-on-one, two children together who can work with each other as they are measuring the water that gets poured into the containers. How many cups does it take to fill the entire bottle? Let's find how many measuring spoons that we have in the water together. We can ask children those activities or those questions as they are working with the materials we want them to be focusing on and exchanging in those conversations together. Next slide and back to David.
So there are some potential obstacles in implementing math language in the classroom. First, sometimes it's hard to incorporate mathematical language into the conversations with children. It may not be part of your everyday language. And this gets back to the starting small and focusing on very specific language and trying to refer to things with both numbers and locations, using quantitative or exact numbers when you're describing something, as well as that more approximate language, like using a lot. There are a lot of things on the floor, as well as let's count them. Oh, there are 10 things on the floor after you've counted them. Try to incorporate language and be very specific, but start small. Also, and I noticed that this was related to one of the questions that was in the chat, many children in classrooms are dual language learners. How can we help them to understand the mathematical words and phrases? I think it's really important to remember that children come into our classroom with lots of different strengths. And dual language learners, they come to our classroom with knowledge in multiple languages, and so we need to think about what do they know in this language, and what do they also know in this language, and how can we connect across the languages for them. What are terms that I should try to learn to make sure that I can connect it with what they already know. So use some words or phrases children are learning several times during activities, and try, if you're able, connect across languages between those terminology, or between the different terms. Next. Then also, when we talk about math, children forget to use the mathematical language they're learning, and that's okay. We forget things all the time. It's important to just keep trying to make this a natural part of children's classroom experience. Treat your classroom as a mathematical environment. Over time, it'll just become more natural for both your students and for you. Next.
Wonderful. Thank you, Peg, David, Julie, and Elizabeth. We will now move on to the question and answer portion. Thank you to all our attendees for submitting your questions in the Q&A box. I invite the presenters to turn on their video screens for this Q&A portion. Thank you. Our first question is, I'm going to actually pose this to the group and anyone can chime in here. The question is, I liked the idea of starting conversations with children about the mathematical language in the book you just read. Can you give us an example or two of how I might do this, say for a sophisticated student and a student at earlier stages of development in mathematics? Who would like to take the first stab at that one?
I can jump in here. And this is something that in my research lab, we've really thought about a lot recently, because like I said before, it's really hard to come up with these questions in advance. So what we've actually done is we've developed a series of children's picture books, and we've embedded questions, mathematical questions on each page that kind of scale from less complex to more complex. That way they're already embedded there. But for you as a teacher, this is something to think about in advance. How some of that advanced planning of trying to think of what is a simpler question that I can target towards a student who has a more beginning development of these skills versus a student who has a more advanced development. So planning in advance is really the best way to try to make sure that you're scaffolding across the different kids in your classroom.
I would chime in on with David's comment about this in thinking about sometimes they happen in the moment, right? And so what do you do in response to the moment? And there's so much richness that happens that when you answer a question for perhaps the more sophisticated child, or that's the conversation, that modeling is really rich for that child who might be at those beginning stages, because they're starting to hear that language and that conversation between you and that student. And so it's really great for them to hear it, even if they may not grasp the entire concept. The fact that they're staying, hopefully, interested in what they're listening to, that's great stages for them to start those steps to getting to be a more sophisticated student or comprehension of that concept. So don't be afraid to do either one. The same for the earlier stage development in math. It's really important too. You might be hitting on other skills like patience and empathy when children who don't understand a concept as quickly as another child does, here's how you explain it to them and those steps that it takes to get that concept shared with them.
Okay, thank you. I'll move on to our next question. I think I'll pose this question to Elizabeth first, but others feel free to chime in. If you are discussing using mathematical language in a story about the beach, and students wander off into talking about their cousin who went to the beach and hurt himself, how do you get them back on track without hurting their feelings? Elizabeth?
So there are two ways that I see this, and a lot of it depends on the group and what's happening in the group. You know, if I'm having a conversation and reading a book with a small group of children, sometimes I'll say to that child, I really want to hear what you have to say, so I want you to hold on to it. And when we finish the story, I want us to come back and talk about this. And sometimes they let me do that, and they will remind me, remember, you said we were going to talk about this at the end of the story. You're right. So you have to remember too, that if you make that commitment, you follow up with it at the end of the story. Other times, children are so passionate about what they want to tell you that it's okay for them to share about their cousin and the beach and what happened. And is there a way to loop it back together or loop it back to the math concept that you were talking about? You know, did they hurt both their legs? Did they hurt all? You know, is there a way to bring it back? And sometimes it's just a matter of what's happening in the group setting. So can they hold it for later and you'll come back to it? Or can they explain it and then you smile and say, thank you for sharing. Now we're going to go back to our story. Some food for thought.
Just to add on a little bit with Elizabeth, and it's also important to, I think, recognize the recency and the impact of an event like that for a child. If it is something that is very recent and has been a little bit traumatic, then you may need to handle it differently than a typical situation where a child just wants to talk and share this fascinating story. So a couple of little things to just think about in there.
Okay, thank you. I'll move on to the next question. This one's for Julie. We have a lot already planned for each day. How can I fit in time for math and still allow the children time to play? Julie?
Well, play math is the easy answer to that question. I mean, math can be so much fun and kids like playing math games. Kids outside of care settings, just in home settings, will naturally count and talk about their world in terms of shapes and what they notice. So it's easy to build on that. It's easy to play intentional games and be very intentional. And it's also, as David said, easy to build on what they're already doing and make it more fun. The key is those teachable moments are going to be so much more, and those games that we find are going to matter so much more if we're paying attention in small group to where children are developmentally. So if we're paying attention to where they are, we're going to be able to pick from a lot of ideas for fun activities to do with kids that meet them where they are. But if we go into every activity thinking, it's math time, I'm really sorry, kids, I have to do this to you. Of course, it's not going to be fun. But if we go in with a good attitude, I think our kids pick up on it, and kids naturally like math.
Okay, thank you. Our next question I will pose to the group. Can you give an example of one easy question and one difficult question for children at different levels? Any thoughts on that one?
It depends on the content and what's being described. I'm looking around to see if I have any of my books within hand's reach, but I don't. But if there, let's say that there's a page in a book that has a lot of an object there. The word "a lot" is a fairly easy word to get at, and so maybe you ask the child, "What on here do you see a lot of?" Versus something more complex. If there's a set of like four apples and like on one side and like 6 apples on another side, which set has or which plate has more apples on it? So those more general descriptive terms tend to be a little easier than the comparative, but the comparative are really important for building up kids' abilities to really understand how to work with numbers and quantities.
Right, because if you don't put those numbers in relationships, then you're not actually using the numbers to further your understanding. So in the beginning would be just talking about quantities in itself, and then moving on to relationships. Same thing can be happening in shapes. Like I said, thinking about a shape as a whole, but then really trying to get children to focus on parts and properties so that they can understand shapes.
Thank you. Our next question is for Julie. Can you share some ideas to enhance mathematical learning at home? Julie?
Well, I should boot this one right to David because reading books, especially math books intentionally as a family is really important. But I will say that there's so many opportunities to engage kids with quantity, and it's not that hard to understand some really simple ideas about development with parents. We have a website separate that's called learningtrajectories.org, which really does help people understand kids' development in mathematics. But if you really talk about those beginning levels of understanding, building blocks with children at home, easy. In fact, my kids always grew up building with those little creamers at restaurants because that was what was there, and we were waiting for our food. And yeah, we went to those really fancy restaurants where they gave you the creamers on the table. But if you kids would start building, we'd talk about patterns. If you have 4 in this row and you have 3 in the next row, how much is going to go in the next row? Playing hopscotch, playing outside, drawing shapes on the sidewalk with chalk. And playing like Don't Burn My Feet is a really fun one. So everybody step on all the rectangles before you have to get to the other side, or you might burn your feet because it's lava. There are lots of things you can do at home to just, whenever in any situation, to bring in either counting or even number without counting. You're going on a walk, point out to children, you're passing by somebody with 3 dogs. Those are 3 dogs. You don't have to stop and count the dogs, but children start recognizing, oh, I'm hearing the word 3, I'm seeing 3, that's what 3 looks like. And actually, that's what's going to help them count, is when they understand what the total already looks like.
Building off of what
Go ahead,
Julie,
David.
building off what Julie was saying, I think one of the easiest things for parents to do is reading books to their kids. And that's something that if you have a classroom library, you can do something where you check out books to kids so that they can take them home if their families don't have the resources to purchase their own books, or send home book recommendations to families that get at the math concepts that are being taught during that time period in the classroom. But also try to think about books that have really good storylines. I mean, those basic counting books aren't the most exciting books in the world, but ones that have a real storyline where math can be drawn out of them, those are sometimes the best. Other options that you can do are providing very simple, resource-free activities that parents can do with their child, just sending it home through email or through a little note, or if you use one of those text apps, things like going on a shape walk. We're going to find everything that looks like a circle, or a number walk. We're going to find things that come in pairs of 2, or things that come in, or find things that come in pairs of 3 or 4, and try to encourage parents to do that with their kids at home.
Just real quick, David, building on that, there was a study in Finland that was really fascinating, where all they did is ask people who were providing early care to kids. I'm talking like 2 and 3 year olds. So I know that's outside the scope of this, but it's still a very pertinent, is to say number words when you were describing something. So if you are going to pass the dogs, say there are 3 dogs or there are 2 dogs. If you're going to say, oh, look at those trees, because the trees are changing color right now. Say, look at those 2 trees that are changing color. If you start using number words all the time, it feels awkward in the beginning, but it means so much to kids because they hear those number words, and the vocabulary, using mathematical terms increases, and it showed to have a huge effect in Finland.
I think also, well, thank you. I think also that games are another way that families can really start using numbers at home. And there's something that children, like card games or board games that involve counting, they're ways that the parents can have a good time with the child, but it builds in a lot of ideas about numbers in a really fun way, hopefully for everybody.
Thank you all. This has been a great discussion. I think we have time for one more question, depending on how much you have to say about it. I'll pose this to the group. Can you talk more about how to work with a small group if there are other children in the classroom? The children are so easily distracted watching their friends.
I've watched quite a few classrooms over the past year via video observations, and I've seen just that. I've seen people really struggle to be able to work with a small group and they are consistently putting out fires around the room, trying to deal with behavioral challenges. And I will say, and I think my colleagues will chime in, that planning is everything. That if you have activities planned for the other children that are engaging, that the more they're engaged, the less challenging behaviors you're going to have, and the less likely you're going to have to go handle some kind of behavioral problem. I will also say that setting up your classroom intentionally so that you can keep an eye on things while you're working with these children is also really important. And then it's just explaining, you're going to get your turn, you're going to play with me next. They have a job to do, and their job right now is to go play in this other center and do that. But Elizabeth lives it in a day-to-day, so you probably have better ideas than I.
I was just going to chime exactly what Julie talked about, which is that planning ahead. So planning those groups, if you know that there's particular children who sort of just gravitate towards each other, and so making a successful small group and have them come together. So they're already there. Setting up your routine, again, that whole planning. If it's a routine that this is the way that centers and group time set up, you're going to get a turn with me next. You'll have your turn when it's time. I'm waiting for this group and do those things. So planning, thinking about how you're going to construct those small groups, who's in them and what you're going to accomplish, and then sticking to that routine so children know what's expected of them. If you're with this particular group, then the rest of the children know that they're going to get their turn as well. So great ways to think about small groups in the classroom.
Okay, I think at this point, we will move on. We were unable to answer all of the questions given our time constraints, but on the next few slides, I will explain where additional questions can be submitted. For right now, I'd like to take the time to thank our panelists, Peg, David, Julie, and Elizabeth, for their presentations on recommendations 3 and 4 and their insightful responses to the questions. This was the second of 3 webinars for this practice guide on preparing young children for school. The first webinar was held yesterday and focused on the first and second practice guide recommendations on social emotional learning and executive function. The third webinar is tomorrow, Thursday, at 12 p.m. Pacific, 3 p.m. Eastern, and will focus on recommendations 5, 6, and 7 on vocabulary, letters and sounds, and shared book reading. This presentation contained just a few examples from the practice guide. The full practice guide and additional materials can be accessed on the What Works Clearinghouse website. As I mentioned at the beginning of this presentation, this webinar was recorded. A link to view the recorded webinar will be shared via email to all attendees who registered for this webinar. The recording will also be available on the IES website. If you have additional questions, please submit them via email to the WWC Help Desk at contact.wwc@ed.gov. Thank you. This concludes the webinar.